Chibueze, or you're welcome to Hosting Laboratory Port Harcourt. Today's episode is will be based on the GBC 7A. That's the popular software for used in analyzing the AS. And for today's session, it will be based on the method. We have several icons we'll be treating, but today we'll be treating the methods, how to use the methods, different outlines under the method. Okay, all right. This is how the GBC 7AA environment looks like. This is how the page looks like, and these are the icons. Here you have the method, and here you have the samples, and here you have the analysis, and here you have the results, and here you have the reports, and here you have the instruments, already looking like the instruments. For this particular episode, we'll be talking on the method, and in our subsequent videos we'll be looking at other icons. Now, for your method, when you click on your method, this is what you see on the method icon. You have your description, you have your instruments, you have your measurements, you have your calibration, you have your standards, you have your quality, and you have your flame. Now, for your description, whichever elements you want to analyze, when you click on this arrow here, it shows you the periodic table. This is the periodic table, and elements on this blue, you can see some elements on this blue. It shows elements that can be analyzed with the air acetylene. Look at them. These are the elements that can be analyzed with the air acetylene. And here you have your matrix, your sample matrix. It can maybe you want to analyze an impacted soil sample. You can just name it impacted soil 1 or soil 2. Just a name, just an identity. Then your notes, you could just write a brief note on it, just more about the soil you want to analyze. Also, here you have your instruments. Immediately you insert your lamp, it gives you your lamp current, it gives you your wavelength, and it gives you your slit width when the lamp is inserted. Though you can choose to reduce it, you can choose to reduce the value. That's when you're trying to optimize the lamp. And also here you have your measurements. You have your measurements mode, you have the read time, you have the time constant, and you have your replicate. Now we have several measurements modes. You have your peak height, you have your peak area, you have your running mean, but the default is the integration mode. And you have your read time. Read time is 3 seconds. That is the time it takes for it to aspirate your samples and for you to get your results in the output signal, that's in your system. That's 3 seconds. And you have your replicates, that's the number of times it reads your sample. All these have been done in seconds. And you have your time constant. Though what your time constant does majorly is just to smoothen the instrument such that you have a good RSD, that's your relative standard deviation. Also, here you have your calibration mode. You have various type of calibration mode, and this particular calibration mode, that's your linear least square. It doesn't force itself through the path, that's through the point. It's not being forced through the calibration point. and it is the default for AES analysis. And you have your concentration units. You can choose to change it that to microgram per liter. What we use is in ppm, parts per million. And you have your concentration decimal. You can choose to put 4 decimal place, 5 decimal place, so whichever decimal place you want to. And we have your calibration failure on. It's either on the R value or the R square value. On the R square value, that is, once you have a value that is less than an R square value that is less than 0.9, it would automatically show you it would not pass. It has to start afresh. So you can, these methods are also your form of quality checking your result also. So you can choose to place your calibration failure on R value or the R square value. Now we have the calibration failure action. What should happen? Should it continue or stop? Should stop. And also the 0 before calibration. 0 before calibration. Now the next one, still on our method, we have the standards. We have the standards, different. There you have your standards, you have your label, you have your concentration, you have your absorbance. If you want to run an analysis, the absorbance value here should be 0 because you don't know the absorbance reading. It should be 0. Everything here should be 0. Should be 0. Should be 0. And you can choose to increase your calibration points. You can increase it to 5-point calibration, whichever number. And also here you can cut it. So that is that about calibration. Your label, you can choose to write iron 1, depending on how you want to label it. You can come here and write iron 2, depending on how you want to label it. Iron 3. Okay, that's that about that. And your concentration, that's what you prepared. If your concentration values are 0.1, depending on your concentration value, and they are being prepared according to DPR limits. And here you have your quality. Also, these are also your forms of quality checking your results. What should happen? You can input your check sample, that is, after 10 or 15 samples you check. And what should happen? What's the fail action? Should you stop or continue? Choose to stop. At what concentration should you use to check your sample? Is it 1 ppm or 2 ppm? These are just to quality check your samples. And here you have your flame. What's the flame type? The flame type we use is air acetylene. I said it earlier in the previous class. And what's the flow? The flow, that's 2 liters in 1 minute. And you have the air flow is 2 liters, 10 liters in 1 minute, and burner angle is set as 0. So this is how your method page looks like. This is how it looks like. In our next episode, we'll be talking more about the samples. So thanks for listening to this wonderful video, and have a nice weekend. Thank you.